Climate change is arguably one of the most important issues facing our planet. And this is a difficult problem because we don't have a full understanding of how much carbon we're producing through man-made sources or how much is occurring from natural sources. And we also don't know how much is being removed through oceanic uptake and photosynthesis. To solve this, we need to be able to measure carbon globally and have a long-term climate record. Both NOAA and NASA scientists have been working on these problems, and that's where my research comes into play. My name's Emily Wilson. I'm the lab chief of the Laser Remote Sensing Lab at NASA Goddard Space Flight Center. I develop miniaturized instruments that measure greenhouse gases in the atmosphere. One of these instruments is a miniaturized laser heterodyne radiometer, and we call that the mini-LHR for short. Our vision is to develop a low-cost global network of mini-LHR instruments that measure greenhouse gases. To do this, we've partnered with AERONET. This is a global network of about 500 instruments that measure aerosols in the atmosphere. We've designed the mini-LHR to operate in tandem with the AERONET sun photometer so that we can deploy our instrument into their network. The way the mini-LHR works is that sunlight that's passed through greenhouse gases in the atmosphere is collected with optics that are connected to the side of an AERONET sun tracker. So we mix sunlight with laser light to produce a beat signal. And from this beat signal, we can then calculate the concentration of greenhouse gases in the atmospheric column. On a daily basis, I work on improvements to the instrument, so I'm working in the lab. I'm also working on proposals and publications. And in addition, I manage the Laser Remote Sensing Lab, which has about 30 people. The most exciting part of my job is testing an instrument in the field. It's a completely different experience to get an instrument working in the lab than it is in the field, for example, on a volcano at 11,000 feet. Instrument development is not like the science that you see on TV, where something big happens all of a sudden. It's slow, steady progress to develop your instrument. You're troubleshooting, you're trying to figure out why things aren't working, you're improving components, and eventually you create a characterized instrument that you can take to the field and deploy. Everybody assumes that NASA is all space flight, but the reality is that here we do a lot of Earth science applications and work on projects to protect our planet. Working on the mini-LHR is exciting because we're going to produce a low-cost instrument that can contribute to the global effort to better understand climate change.